Hey, we're live. GM, guys. GM, how are you? How are you today? Yeah, OBS is a bit buggy for me, but should be should be fine. Should be fine now. Uh, yeah, we're gonna look at the DYAD contracts. It's gonna be fun. We are live. Awesome. Yeah, let's wait for some people to get in here. Let's open up the GitHub. GM coffee, GM man. What's up? Let me get something to drink. What's up? What's up? Nice. Yeah, we're gonna walk through the new updated DYAD contracts. We just finished our Code Arena audit. And one solo audit. Yeah, so hmm, let's see. Mm, this is the branch I want to show. Looks like a GoPro. Yeah, it's like the cheapest camera lying around at my parents' place. Stream keeps lagging. Oh. How's the sound though? When we look at code, should be fine. My upload speed is terrible. My upload speed is terrible, unfortunately. But yeah, Coffee, if you can tell me if the sound's good, we should be fine. This sounds good, should be fine. Okay, so yeah, we're gonna look at DYAD. We're gonna look at DYAD v2. Look at DYAD v2. %65 drop rate is bad on the OBS. Your computer must be streaming. Uh, yeah, I don't know what to do about it, to be honest with you. Like the computer I'm on should be powerful enough. I just think my internet speed is horrible. I don't know. There's something we can okay. I think we'll just start, and this is recorded. So if it's too bad, you can always go back and watch the recording. Yeah, not the most professional setup I have here. Can I play a sound when someone puts something in the chat? I don't know. Okay, then let's start this. Maybe a bit of music would be nice. Okay, so unfortunate that this plugin is broken for whatever reason. Well, let's give it. Let's see if this does something. Okay, good. Sounded good, but stream is pausing to buffer like every 3 seconds. Oh wow. Yeah, that's bad. That's really bad. Yeah, I have a horrible internet connection, unfortunately. I don't know, like, can I... OBS, video quality. I don't know, maybe decrease. Yeah, maybe decrease the output. Video bitrate. No. Maybe. Maybe this does something. I don't know though. What does this look like? Okay. Let's just start. All right, so yeah. Okay, we're gonna start with the Vault Manager v2. The Vault Manager lies at the heart of the DYAD ecosystem. Everything flows through the Vault Manager. So what you can do is you can do a deposit, you can do a withdraw, you can redeem, you can add a vault, you can remove a vault, basically all the functionalities that we already have. And in order to interact with the DYAD ecosystem, you need a DNFT, a DYAD NFT, which if you have minted it already, we are not redeploying the DNFT contracts. They are staying the same. So you use your DNFTs that you already have for interacting with V2. Okay. So every DNFT has a specific number of vaults. So here inside this mapping, we store, we have a mapping from uint to an address set. Each address holds a vault that you can add to your position. So we have an add, and we have a remove, DYAD takes in a DNFT. The message to the sender has to be the DNFT holder, and you add you add a vault that is inside the DYAD ecosystem. I'm gonna explain how vaults get into the system in a bit. Okay. In a bit. And we have a remove. It's, you know, symmetrical. It's basically, it does a different check, which would be interesting to talk about. But this is for removing a vault from your position. Okay. So these are the vaults. So we have add, and we have remove. Okay. So how are vaults added to the DYAD ecosystem? We have a vault licenser, which is currently owned by the multisig, and the multisig goes in and adds or removes a vault, or basically adds a license to a vault. So if you wanna, for example we have a rep ETH vault, the multisig would call add, put in the address of the vault, and then we have this kerosene feature that we're gonna talk about later, where you basically have to say, okay, is it a kerosene vault, or is it a vault that holds I hate this word. It's not exogenous collateral. I always say exogenous. Exogenous. Okay. Okay, so this is how we add vaults to the DYAD ecosystem. And basically, when you add a vault to your DNFT position, we check, is it licensed or not? Okay, there are a max number of vaults, which is currently 6. So we check, okay, is it licensed, and do you still have a spot left? If that's the case, the vault is added to your vault's position. That's basically how adding vaults to your position works. Let's talk about remove. So remove is pretty similar. We don't need to check if it's licensed or not, because what's the point? It's already inside your DNFT position. But we need to check if you have collateral inside your vault. And that's because of how the liquidation works. If you had the ability to remove collateral, to remove vaults while you have collateral in it, you could trick the liquidation mechanism, which obviously would be bad. Okay. So, and you can only add a vault if you're the DNFT owner. So the DNFT owner is a basic check. DNFT owner of ID is the message sender. external, which is stored inside this address set, which is from OpenZeppelin, which is a set implementation. I wasn't aware of this like a couple of months ago, so I actually used this custom set implementation because I wasn't aware this existed in OpenZeppelin. But it's really nice to have this. Okay. Okay, next we're gonna talk about depositing collateral inside the vault. So let's see. Deposit. As you can see, the deposit function calls the deposit function of each vault. So how this works, it's basically, one could have done it by directly calling into the vault. So instead of calling the deposit function of the vault manager, you could have just deposited directly to the vault, but we don't want this because, for example, we need to check the last deposit globally into any vault because of flash loan attacks. So let's look at the vault. Okay. So let's follow this flow. Last deposit ID. Okay. This is for flash loan protection. So here you have withdraw. And here we check if last deposit is block number. So basically, so you cannot deposit and withdraw in the same block to avoid flash loan attacks. Okay, so we get the vault, and then we transfer the collateral from message sender to the vault. Oh, actually, what I see here is you don't need this. You don't need this. You don't need this address casting thing. Okay. So we do a safe transfer from message sender to the vault with the amount. Safe transfer from is from Soulmate. Actually, quite interesting that no one has seen the unnecessary casting here. Probably the compiler just removes this, but why have it in there, I guess. Okay. So, okay, so once we, let's see, let's follow this. The deposit goes into the vault deposit. And the vault deposit, all it does, so it's gated by only vault manager, so only the vault manager can call into this. Just increases ID to asset, which is a mapping from the NFT ID to the amount of collateral. Yeah, this is the deposit function. Pretty simple. It's insane how long this takes, because it's using VAR. Oh, no, it's done. Okay. So, deposit. Let's take a look at withdraw. So we have a couple of checks. Cannot withdraw in same block. This is the flash ROM protection. Then we get the vault. Then we get call into the vault to get the to call withdraw. ID to amount. Always change your state before you do the transfer. Okay. Exogenous collateral and the carousel. Okay. So get vaults values returns the value of the exogenous collateral and the kerosene collateral. Okay, so I think it's time to talk about kerosene. Kerosene is an ERC20 token, and we have a unbounded kerosene vault. Unbounded means you can deposit it into the vault and withdraw it. In a bounded kerosene vault, you could only deposit it. And what's special about kerosene? What's special about it is it has a deterministic asset price. And the asset price of kerosene depends on the TVL, the DYAD total supply, and the kerosene in circulation. And basically what you can concentrate on are these 3 lines of code. So basically kerosene is TVL minus DYAD total supply divided by supply of kerosene. Okay? So if the supply of kerosene goes up, its price goes down. If the TVL goes up, its price goes up. If the DYAD total supply goes up, its price goes down. So it's just interesting mechanic. Actually, I wanna I don't know, stream or something. Commit unnecessary casting. Damn, it's raining like crazy now. It's raining like crazy. Okay. So this is kerosene. So again, to summarize, kerosene is a ERC20 token that has a deterministic price that depends on TVL, the DYAD total supply, and the kerosene supply. Okay. And you can add kerosene to your position. Okay, you can add this unbounded kerosene vault to your position, and it basically counts towards your collateralization ratio. Okay, so if we go back to the Vault Manager v2 and check how the collat ratios. Okay. So this is how the collateralization ratio is calculated. It calls into green is internal call. Okay. It calls into get total value. So let's take a look at collateralization ratio. Collateralization ratio gets all the DYAD you minted, which is basically your debt, and it gets the total value you have, just your collateral. Let's take a look at get total value. So your total value is your exo value and your kerosene value. And get vaults values returns that. Returns exo value and kilo value. Exo value would be something like repped ETH or staked ETH, which we have right now, and hero value would be kerosene value. So let's check out get vaults values. I think this is very clean, by the way. The total value for a DNFT is the exo value and the kilo value. Exo value. I'm not gonna pronounce that correctly. Okay. So get vault values, as we said, returns the exo value and the kilo value. Let's see how it does that. Number of walls is the number of walls for your DNFT We iterate over every vault. We get the vault. We check is it licensed, and if it's licensed, we check the vault licensor. Is it a kerosene vault? If yes, put that into the kilo value. If no, it's an exo. It's an exo value, and we increase that. And at the end, we return both. Exogenous. Exogenous, okay. Nice. Vaults value. Okay. So the collateralization ratio, if we go up again, gets the exo value and the kilo value. So the kilo value, the kerosene value, is like exogenous collateral for your collateralization ratio, which is a way to save yourself from liquidation. because inside the liquidation function, we only check the collateralization ratio. Okay, this is why kerosene is very useful. Okay. So yeah, let's go back to withdraw again. And talk about this. Okay, when you withdraw collateral, okay, first of all, when you call this, what could be changed is the amount of exogenous collateral, the amount of kerosene value, one of them, not both, and it changes the collateralization ratio. So we have to do this withdraw, which is very important. We have to do withdraw before we call this function. If we did it like this, we wouldn't get the updated value, which would be a big bug. Okay. That's why I have this comment here, because it's really, really important to keep in mind and very easy to mess up. Okay. Once we have that, we get the minted DYAD. And then what we check after withdrawing, we check, okay, is the minted DYAD less than the exogenous collateral value? And if yes, we revert. So we always want to make sure that at least $1 worth of exogenous collateral is available for every DYAD. At least. Okay? Which is less, obviously, than the over-collateralization ratio limit. The minimal collateralization ratio is 150%. Okay? But the kerosene to minted DYAD limit is basically 100%. Is one way to think about it. Okay. So after that, we also make sure, okay, are we still over the collateralization ratio or not? Are we still over the collateralization ratio or not? Okay. Because actually, let's think about this together. Could there be a case? Okay, what's the case where we pass this, but we if the kerosene price gets it's crazy, then one of like the collateralization ratio could fail. Okay. This is the withdrawal. Take a look at withdrawal again. Mint DYAD. Okay, obviously we also have a function to mint DYAD. And the checks that we have here are very similar to withdraw function. They're so similar, but actually that, like if you look at these lines, They're the exact same lines as this. Could be a nice refactor, actually. Thinking about it. Like it's this exact same code. Okay, what are we checking here? We basically check the amount of exogenous collateral and the collateralization ratio. What would be a good function for this? Let's ask ChatGPT. What function name for this? Check collateral ratio and values. Give me I don't know. Could be something like that. Let's see. XCR, check EXO, value, and collect ratio. Something like that. Just want to make sure it does the EXO value clear value, vented, EXO, do int, I think that's a refactor. And then you also can do like this. like exogenous value and collateralization ratio. Yeah. So we meant DYAD check exogenous value. I think this is an answer vector. Withdraw, exogenous, check exogenous value and collateralization ratio. Okay. Add commit refactor. I think that's a nice refactor. I think that's a nice refactor. Burn. DYAD. So actually, yeah, let's take a look at withdraw and mint. I really love the symmetry because, you know, withdrawing and minting DYAD, all operations that decrease your collateralization ratio in different ways. Like this increases your debt. This increases your debt, and this decreases your collateral. It's nice to have that. It's nice to have that symmetry here. I'm thinking about the national protection. But now you can only mint more DYAD if you increase your exogenous. If you increase your exogenous collateral, and yeah, which you cannot do if you cannot withdraw. Deposit, withdraw, mint DYAD. Check exo value and collateration. Okay. I think that's nice, but we don't need this. Internal view. Internal view. Check exogenous value and collateration. New int ID. Internal view. It's definitely not pure. Can we... I would like to regenerate this diagram. Yeah, it's actually quite involved. Because the calculating the collateralization ratio is a loop over our vaults, fortunately. Is what it is. Okay, and by the way, we have this collateralization ratio function, and we have an internal one. Because in certain operations, I don't want to recalculate this total value thing. So why do we have the same function with different arguments? I mean by that the collateralization ratio. Sometimes we can reuse the minted DYAD, which is an external call, and total value values. Calculating them is expensive, so we can reuse the cache values. So let's see an example. Here, for example. I could have called the collateralization ratio function again, but the collateralization ratio function does this, get vaults values, which is very expensive. Because we're iterating over every vault, and we call the getUSD value function. The getUSD value function is also very expensive because this is our oracle.